All right, in this video we're going to be talking about Venn diagrams and set operations. And really this is just a basic introduction. And I'm sure most of you have seen Venn diagrams before. They're used to describe simple relationships between a few sets, 2 or 3 sets usually. And so we're going to go ahead and look at this in some detail. So first of all, there's 4 basic relationships between 2 sets. The first type is what we call a disjoint relationship, or we say disjoint sets have no elements in common. So as an example, if you say A is the set of cats and B is the set of dogs, well, certainly there are no members that are in both sets. So these are disjoint sets. Now notice here it says U is the universal set, the set of all elements under consideration. Now for the example I just gave you, it's not obvious what U is. It might be the set of all animals, or it might be the set of domesticated animals, or it just may contain these 2 sets of cats and dogs. It's not always clear what the universal set is, although with the problems we're going to be doing, it'll be pretty clear. On number 2, we have A is a proper subset of B. Remember, that means A is a subset of B, but A and B are not equal. And so, for example, if you said A is the set of poodles and B is the set of dogs, then we would say A is a proper subset of B. Every poodle is also a dog, and of course these are not equal sets. All right, let's look at number 3 here. It says A and B overlap. Or in fact, we write it this way, and this is read A intersect B. In other words, A and B have at least one element in common, and we describe this overlapping set as A intersect B. And in fact, this is probably the most common relationship that we see between 2 sets when we're looking at 2 sets. And so let me give you an example. We could say A is a set of students and B is a set of people who work. And of course, there's at least one person that's a student and who works. In fact, many students work. In our book, they'll sometimes put an X to indicate there's at least one person in there. But normally, if you have overlapping circles, we can assume that there is some intersection there. I guess it's not always true, but in general, if you just see 2 sets, normally there is something in there if they're overlapping. All right, if we look at number 4, we finally have the situation where A equals B. Now this is probably the least interesting case. In fact, it's a little hard to think of 2 sets that we would describe differently that have the same elements. So I came up with the clothes I wear to work and the clothes I wear to church. All right, let's move on to the next page. On number 3, it says identify each described region using the correct Roman numeral. So you can see in the universal set here, there are 4 different regions. 1, 2, 3, 4. And notice we use Roman numerals to label them. And so what I want you to do is just see if you can do A through D here and make sure you understand exactly how we would describe these 4 regions. All right, so in A, it says in A and in B. Well, that would be in here. So those are the members that are in both sets. And so that's region 2. In B, not in A. So that would just be this area here. And so that's region 3. Not in A or B. That means we're not in either of these at all. And that puts us in 4. And so by the process of elimination, you know that the last one must be the first one. But in A, not in B, that would definitely be region 1. All right, and number 4, we have a little bit of vocabulary that we're going to talk about here. So the first one is the complement of set A, symbolized by A, and it's like an apostrophe, but and we say A complement, or sometimes people say A prime. So let me just write that, A prime, or A complement, is a set of all elements in the universal set that are not in set A. All elements in the universal set that are not in set A. Okay, so for example, if U, our universal set, is the set of natural numbers from 1 to 6, and our set A is the set with 2, 4, and 6 in it, then we want to take all the elements of U that are not in A. So to find A complement, really all you need to do is cross out all the elements that are in the universal set that are in A, and whatever's left over is going to be A complement. So here that would be 1, 3, and 5. I'm going to go ahead and draw a picture of this for you, or Venn diagram. It would look like this. So you can see that 2, 4, and 6 are inside set A, which is in the universal set, and 1, 3, and 5 are outside of set A and are in the universal set. All right, let's move on to the next slide. So the intersection of sets A and B, which we actually already briefly discussed, symbolized by A intersect B, and it's like an upside down U that's the intersection symbol here. So we basically read this A intersect B. So A intersect B is the set containing all of the elements that are common to both sets A and B. Draw a Venn diagram to illustrate. So the key here is it's basically what the two sets have in common. So you're looking at two sets and you want to see what they have in common. We call that the intersection of the two sets. So here's a picture of that. So you can see we have sets A and B, and the part I shaded is A intersect B. All right, number 6. This is the union of sets A and B, symbolized by its A union B. And this time our symbol looks like a U, basically, a capital U. So A union B is the set containing all of the elements that are members of set A or of set B, or both. So this is generally the way I should say this is how we define the word or in mathematics. It means it's in the first set or the second set or both. One or the other or both. Draw a Venn diagram to illustrate. It would look like this. Well, first of all, I want you to think of the word combine when you think of union. We're basically just combining the sets together. And so our Venn diagram looks like this. Notice I'm going to take all of A and combine that with all of B. And so that's a picture of A union B. So everything that's in A and everything that's in B. All the elements in A and all the elements in B. All right, let's move on to the next slide. So this will be our last one, and let's see if we can put this all together now. We've talked about A complement, A intersect B, and A union B. So here we have a universal set that goes from it's A, B, C all the way through H. We have set A with A, G, and H in it, set B with B, G, and H, and set C with B, C, D, E, and F. So let's go ahead and find A intersect B. Well, remember, intersect, that has the idea we need to find what the two sets have in common. All right, so if you look at A and B, well, let's see. They both have G and H in them. And so A intersect B is going to be the set G and H. How about A union B? Well, A union B, remember, we want to remember the word combine. We're going to combine these two sets together. So I'm going to take everything that's in A first. That would be A, G, and H. And then I want to add to that anything in B that I don't already have. Well, I already have G and H, but I don't have B, so I need to add B in here. Now, normally we'll change the order so that it's in alphabetical order, so we get A, B, G, and H. All right, A complement. Okay, so A complement is all the elements that are in the universal set that are not in A. So if you literally cross off, let's see, A has A, G, and H in it. So what's left? Well, basically B through F. And so that's going to be A complement, B, C, D, E, and F. All right. In letter D, we have to find A complement intersect B complement. Well, we already have A complement right above, so it might be helpful to find B complement first. In fact, pretty much have to do that at this point. So B complement is everything that's in the universal set that's not in B. So I'm going to cross off B, G, and H. You can see that B complement is going to be A, C, D, E, F. So let me go ahead and write that out. So A, C, D, E, F. And so now we actually have these two sets right next to each other. And so we want to see what they have in common. Well, they both have C, D, E, and F. C, D, E, and F, C, D, E, and F. And so that's going to be our answer here. The set with C, D, and E, and F in it. All right, let's look at E. So here we're finding A union C complement. We don't already have C complement, so let's get that first. So C complement will be everything in the universal set that's not in C. Well, C has, let's see, B, C, D, E, F. So basically from B through F, so that means that C complement will have A, G, and H. Now, in fact, A and C complement are the same. So if you combine them together, you don't get anything new. So we're just going to get A, G, and H. In fact, that also could be written as just A. Either one of those is fine. All right, on F, we're going to find the complement of A intersects C. So first of all, we should find A intersects C. So what did A and C have in common? Well, let's see, A, G, H, actually they have nothing in common. And so we would say that A intersects C is the empty set. Well, what's the complement of the empty set? It would be everything that's in the universal set that's not in the empty set. Well, that would be the universal set. All right, let's move on to G. Now, I would encourage you to try the second column here and see if you can do all of these. Some of them, well, most of them are a little bit different, but you're going to be using the same ideas. All right, so let's look at G. So I'm going to go ahead and put A complement and C complement here. We already found those. And we want to union these together. So we have A, let me change colors here. We have A, B, C, D, E, F, G, H. So in fact, we have it all. That's just going to be the universal set. On H, we want to find the complement of A union B. Well, we already found A union B on problem B, and it was A, B, G, and H. And so the complement of that is going to be everything in the universal set that's not in this set. So I'm going to go ahead and cross off A, B, G, and H. And you can see what's left over is C, D, E, F. So C, D, E, and F. That would be our set. All right, let's see how you did on these last four. So A union the empty set. So if you take everything that's in A and you combine that with everything in the empty set, well, that's not going to add anything new. You're just going to have set A. If you look for so now we're in J, A intersect the empty set. Well, what do these two sets have in common? Well, there's nothing in the empty set, so there is nothing that they have in common, and so this is just the empty set. On K, we're finding A union the universal set. Well, if you combine the universal set with any other set, you're going to get the universal set itself. And then finally, A intersect the universal set. It's everything that's common to both sets. Well, that's going to be everything that's in A. All right, and so that's it for this video.